If the couple moment acting on the pipe has a magnitude of 400 Newton meters, determine the magnitude F of the vertical force applied to each wrench. So to answer this question, all we would need to do is find the magnitude of this distance, that perpendicular distance between the forces. Then do F times that distance and set that equal to 400 and solve for F. But just to illustrate this, I want to find R cross F. Let's get this moment, this couple moment, as a vector. Because yes, couple moments are easy to work with. They're free vectors, but they're still vectors. They can be oriented in any direction in 3D space. When you do a vector sum on couple moments, it's not always just a scalar sum. It's a vector sum. You might have a couple moment in this direction, and this direction, and you do a vector sum to get the net resultant couple moment. So for a couple moment, it's R cross F like a regular moment, but the R, you go from any point along the line of action of minus F to any point along the line of action of F. And that's the R, any point. I'm doing it from these positions because we've got the coordinates relative to those positions. And you just go from minus F to F because then you think of, you take with the right-hand rule R cross F, and that will give you a vector that is rotating, a vector that represents rotation in the direction of the couple moment. That's the whole idea. The R cross F ends up with the curl of the fingers in the direction of rotation and the thumb pointing in the direction of the vector, the couple moment vector. So this is R. Let's get the position vector R. So RAB, XB is 300 minus XA, 300 plus 200 plus 150, 650. Okay, YJ is 200, or YB, and then YA is 400. And then there is no component in the Z. This doesn't, we don't go, going from A to B, we don't go up or down. So R is minus 350I minus 200J. What is F? It's F K hat. We're doing R cross F. That's the couple moment. It's R cross F, where R is directed from any point along the line of action of the negative F of the couple moment to any point along the line of action of the F couple moment. So the couple moment, I guess we'll put C for couple, is R cross F remember, this is just a magnitude. So doing this cross product, 350F, and then cross in the minus I hat with the positive K hat gives you positive J hat. So put your right hand along the negative I hat, push that negative I hat to positive K hat, and your thumb's in positive J hat. Then minus J hat cross K hat. So we'll have 200F and then minus J hat cross positive K hat. Right hand and negative J hat, push to positive K hat. That's minus I hat. So minus 200F I hat. So that's the direction of the moment vector. So it's like, so we go a certain amount in the J hat and then a certain amount in the negative I hat. So kind of like something like this, which makes sense, right? That's where we're perpendicular to R and the plane of R and F. Okay? But what do we know that the magnitude of this vector is 400. So we can say that 350 F squared, so plus 200 F squared. We could put minus, but it doesn't matter. Square root of that is equal to 400. So okay, so we can add these. To 82,500. Okay, now square root of this. $531.5. Now, wait a minute. Hold on. I messed this up. This is, we need to change this 400 to Newton millimeters because all these, this 350, all that's in millimeters, right? So I didn't have the units right. So 400 Newton meters times the fact that there are 1,000 millimeters in 1 meter. So 400 Newton millimeters, 400,000. So F we've got 753 newtons. Okay, and I messed up also. For some reason I put here, so I did 350 squared and then I did 400 squared instead of 200 squared for some reason. So 200 squared is 40,000. So this needs to be 40,000. Then 40,000 plus, okay, 162,500. And then the square root of this is 403.1. And then 400,000 divided by 403.1, 992.